In this section, we're going to be talking all about exponents, and we're going to be exploring different rules of exponents and how to work with them. But before we do that, I want to kind of just do a quick review about what an exponent truly is. So normally whenever you see something in exponential notation, it looks something like this 3 squared here does. Now those different parts have specific names, and it is really important that we know those names, part of our vocabulary. So like in this 3 position here, that number is called the base. And then the 2 that's written as a superscript, or up above, that is the power or the exponent. So those are the vocabulary that you're going to need to be able to work with your exponents. Now, just a quick review of how exponents work. We have this that says, what does 3 squared mean? And not just popping it off the top of your head, but really think about what it means to square something. That means that we take it times itself, right? 2 times. So 3 squared literally means 3 times 3, which we would know to be 9. But what about this next one that says negative 3 squared? This time we have a negative 3 in parentheses. That's telling us that our entire base now is a negative 3. So we have to multiply it, the negative 3, to itself 2 times. So that literally says negative 3 times negative 3, and the negative times the negative would make it a positive 9 again. Now the next one looks almost identical to that, just slightly different. We have the negative 3 not in parentheses this time, and we want to know how much of a difference does that actually make. Well, it makes a pretty big difference, actually. In my classes, I always say that I stole from a friend, a little saying, if this exponent were to grow an arm and reach out and touch something, the first thing that it would touch would be the 3. That tells us that it's actually the 3 that's being affected by the exponent. It is only the 3 that is being squared. And then the negative is on the outside of that. This is absolutely an order of operations type problem here. So we would need to square our 3 first. 3 squared would be 9. And then we have to take the negative of that, or the opposite of it. Another way you could read this would be to say the opposite of 3 squared, which would be negative 9. Now, once we can work with exponents, then we can actually start evaluating expressions that have exponents in them also. So we have this expression here that says 2 times x times y squared. Now, any time that I replace a variable with something, I always use parentheses, just to be on the safe side so that you don't make any sign errors. So let's rewrite this expression. But in place of the variables, let's put in parentheses so we know we're going to be replacing those variables. So I would write that as 2, and then I'm going to leave a space to replace the x, and then I'm going to leave a space here to replace the y, and then we have to square that. This helps me also to be able to see that the only thing that I'm squaring here is whatever this y value is. The only thing that's being affected by the power is just the y. Now we can begin replacing. Instead of x, they told us to use a 3, and instead of y, they told us to use a negative 5. Now, this is 2 times 3 times negative 5 squared. You'll have to do the exponents first. Order of operations say they come before multiplication. So negative 5 squared would be negative 5 times negative 5, which would be 25, and I'm recopying everything else. Now, we move left to right because all we have is multiplication. So 2 times 3 is 6. Times 25 would be 150. So our final answer there would be 150.